Hello friends. Before we go on to see classification of radiation, here is the ultimate clinical question which arises. When this traveling energy finally collides with a human cell, what actually happens inside the atom of this cell? Listen carefully. When radiation strikes an atom, there are two completely different events that can occur. And understanding the difference between these two events is the absolute non-negotiable prerequisite for everything else you will learn in next few slides. Before we begin, for those who are new to this channel, I am Dr. Parveen Ahlawat. I am a consultant at Rajiv Gandhi Cancer Institute and Research Center in New Delhi for over 12 years. I have been practicing and teaching oncology for more than a decade. I did my MBBS and DMRT from CMC Vellore, did my DNB at Rajiv Gandhi Cancer Institute, pursued a fellowship at the Royal Marsden Hospital in London, and have later undergone specialized training in cyberknife from the United States. I have published almost 85 research articles and abstracts in PubMed indexed international journals. Imagine a low energy photon colliding with a stable atom. It transfers its energy directly to an orbital electron. But here is the catch. This photon simply does not have enough energy or power to knock that electron completely out of its orbit. It only has enough energy to temporarily push that electron into a slightly higher, unstable orbit. The atom gets excited briefly and the electron falls right back down into its own place. We call this event excitation. Because this radiation lacks sufficient energy to remove an electron, it cannot alter the atom's chemistry and does no significant harm to the cell. It cannot break chemical bonds and it absolutely cannot damage human DNA. That is what we call non-ionizing radiation. Non-ionizing radiation. But now look at the right side image. This is where the magic of radiotherapy happens. Here, a high energy photon strikes the atom. This energy photon gives a massive, violent punch to the orbiting electron. It has sufficient energy to physically eject an orbital electron entirely away from its stable atom. This complete removal is called ionization. It is also called as ejection. The previous phenomena was excitation and this is ionization or ejection. When this electron is ripped away from its atom, the atom becomes a highly reactive ion. It is called ion. The chemical balance is disrupted now. Bonds break, and most importantly, this is the exact property that permanently damages DNA and kills cancer cells. So it is the ionization which destroys a cancer cell, not the excitation alone. I want you to keep these two concepts, excitation and ionization, burned into your memory. We will use these words very often in next slides. Many newly joined radiation oncology residents have a very common wrong idea about what radiation is. They think radiation is only the X-ray beam which comes out of a linear accelerator gantry head kept in their radiation department, or X-ray which comes out from the X-ray machine for taking chest X-ray kept in their radiology department. This is simply not true. Radiation has a very broad meaning and is a very big physical event. I am going to teach you the full picture and classification of radiation today. This slide shows the classification of radiation. This is an important slide and I am going to spend a lot of time on this slide to explain you. So listen and watch carefully. Look at this complex and busy flow chart. There is some overlap between some types of radiation. Let us understand it. We can categorize radiation in two simple ways. Each way then has further sub-classifications. The first way to classify radiation is based on its physical nature. Physical nature means what radiation is actually made of. The second way of classifying radiation is based on its ionizing potential. That means what radiation does to the matter. Okay? So this is the broad way to classify radiation. Let us look at further subclassification of radiation based on its physical nature. By its physical nature, radiation is divided into two main types. The first type is particulate radiation. Particulate radiation. And the second type is electromagnetic radiation. Electromagnetic radiation. The word particulate means an actual physical matter having some mass. So the particulate radiation is made of actual tiny particles. They have some mass. They may carry some electrical charge. They travel very fast but always slower than the speed of light. Examples are alpha particle, beta particles, protons and neutrons. The second type is electromagnetic radiation or EM radiation. This is completely different type of radiation. It has absolutely zero mass and zero charge. It travels as packets of energy called photons at exactly the speed of light. Electromagnetic radiation is again a very large family of radiation. It can be divided based on how much energy it has. If it has enough energy to completely remove an electron of an atom from its orbit, we have given it a name, ionizing electromagnetic radiation. X-rays and gamma rays, which are workhorse in our departments, are example of ionizing radiation. All of us have linear accelerator, where high energy X-ray is used to treat cancer. That is an electromagnetic radiation. Some of you who have telecobalt machine at your center use gamma rays to treat cancer. All of us have iridium radioactive source for brachytherapy treatment. Some of you may have cesium radioactive source for brachytherapy. These iridium and cesium both generate gamma rays which we use to kill cancer cells. If the electromagnetic radiation does not have enough energy to remove an electron from its orbit, it is called as non-ionizing electromagnetic radiation. It can only cause atomic excitation, not ejection of electrons. Radio waves, microwaves, infrared rays and visible light are examples. Since it is not ionizing and cannot eject an electron, it is not harmful to our body directly. We are exposed to this type of radiation all the time. Now we move to the other way of classifying radiation. This is based on how much ionizing potential a radiation type has. or how much energy a radiation has. This is the most exciting part of our clinical work. This tells us what radiation actually does to a living cell. Here, radiation is either ionizing or non-ionizing. Ionizing radiation are, again, as I told you, here are those types of radiation which has sufficient ionizing potential or energy to eject an orbital electron from a stable atom. Once again, ionizing radiation are those types of radiation which has sufficient ionizing potential or energy to eject an orbital electron from a stable atom. This is the property of this type of radiation that kills cancer cells. Ionizing radiation are of two types. Particulate types, which includes alpha, beta, protons and neutrons, and electromagnetic types, also called as photons, which includes high energy X-rays and gamma rays. As I told you here, a linear accelerator produces high energy X-rays. Brachytherapy with radioactive source produces gamma rays. When we treat top layer of skin cancer, we might use beta particles. Some very advanced hospitals use proton beams. These are all different physical tools for treating cancer, but they all belong to ionizing radiation. Finally, look at the bottom right. Non-ionizing radiation does not have sufficient enough energy to eject an electron out of its orbit. All that it can cause at most is excitation only. There are no particle radiation in this group. It is only electromagnetic waves. For example, radio waves, microwaves, infrared waves, and visible light. You must remember these two simple ways to classify radiation. These are two independent ways of classifying radiation. There is some overlap, you don't get confused with it. You must always know if your treatment tool is a particle or a photon, and if it can ionize atoms. So keep this classification in mind about radiation. The classification of radiation may look complex and confusing at this moment, but you must be very clear about it. Most beginners remain confused about the types of radiation. In next video, I will teach you electromagnetic spectrum. Thanks for watching. Signing off, Parveen Ahlawat.